Welcome back. In this series of videos, we're developing a sample Microsoft Access database application based on the model of the actual time and billing database application I use with my own customers. We started out by creating a table for our customers, and then as we started looking at the business rules that applied to our customers, we realized we needed to make that a little bit more sophisticated and handle the existence of a DBA, or doing business as designation, for some of our customers. We created a separate DBA table and then realized that as we analyzed the relationships and the structures of those first two tables, that we could actually combine them and include the DBA for customer ID field in the customer table directly. And that way we can eliminate a couple of other problems: redundant data and an extra table. As you probably recall, the way this works is Western Washington Builders has 3 DBAs, and that's designated by this self-join key here. In turn, Rainbow Ridge has 2 phases, and again, the link or the relationship is identified by this customer ID in the DBA for customer ID field. So we can build any level of hierarchical structure we want with this very simple now design. Our next step is to begin looking at additional information about our customers. What else do you need to know? We need to know their phone numbers, their addresses, email addresses, and so on. Now, obviously, having just gone through this whole process of resolving DBAs, when you look at my next sample here, you should recognize very quickly, I hope you recognize here, that this table now has the same sort of problem that we dealt with by working out the DBA relationship. That is, each of these fields, owner home phone priority, owner work phone priority, and so on as we go across. And I didn't try to make this an exhaustive list. And as a matter of fact, there's additional phone types we could use. We could say home. We did identify home, work, mobile, fax, but there could be another personal phone number, a main switchboard in the company, a fax for the company, and other company phone numbers. So this could become a very wide table simply by trying to accommodate all of these phone types as separate fields. We know by now that that's not a good design. That's what we refer to sometimes as a spreadsheet design or a repeating group. So rather than blow our table up like this, we're going to create a second child table. So first, let's close this. Okay, now you can see the customer table, the phone child table, and the 2 supporting lookup tables for phone type and priority. The way this works now is that we got rid of our redundant repeating group fields in customer, and we're looking now at just the original basic customer table. We created a second table, and I went ahead and did this to move ahead a little more quickly. This one, it looks somewhat similar to the original customer DBA type table, but it has different fields, of course. It still has the foreign key to customer, so this customer ID points back to this customer, primary key and the related foreign key. It has two data points regarding the phone number itself and any extension. The priority ID tells me whether this would be the first choice, the primary phone number, the second choice, the third choice, or if it's an old number that is no longer active. I don't want to delete old data unless it's really completely useless. In this case, I'm going to retain inactive phone numbers for clients just in case I ever run across a situation where I have an old record using that phone number, and I can use that then to trace back and find the right client by looking up that old phone number. If I were to delete the phone number when it goes inactive, I would lose that link to history. Phone type tells me which of these types, and because this is a lookup table with many rows, we don't have to worry about building a wide table. We can simply say this one is a mobile phone, this one is a work phone, and we have this again foreign key relationship with this primary key that allows us to indicate I want to use this phone, which is my mobile phone, as my primary or first place choice to make a phone call to me. This is an old phone number which I no longer use. It is inactive, and it was an old work number. Now, this design allows me to assign as many phone numbers as I need to each of my original customers. I can say 2 for this company. Bob's Dry Cleaners may have 1. And that will be his primary because it's the only one. And that's also a mobile number. I've noticed that a lot of people, especially recently, use their mobile number or their cell phone as their primary number. However, when we get to Washington Builders and the DBAs and sub-DBAs that belong to that entity, that customer, I start to get a little bit of discomfort about how I'm doing that. Here's why. I can say customer 2, Western Washington Builders, uses as their primary number, and that is the main switchboard. But also, each of my 3 DBA entities also can be reached at that number. And as you can see, as I continue to add these, and I would probably add 2 more for these phases, I'm seeing the same pattern that we wanted to get rid of in our original customer-to-customer DBA table. That is, these are redundant. They're here. This particular number is here 4 times, once for the parent and once for each of the subsidiaries. And of course, if I were to continue, there would be 2 more for each of the phases of that one DBA or subsidiary. So this doesn't look so good to me because I really don't like to see redundant duplicate data. There's a way to deal with that. and we'll show that to you next. What we're looking at now is a very commonly implemented approach. And I will show you the other approach and then compare the two. This particular approach has proven to be adequate for a lot of cases. So just because I'm going to show you an alternative, that doesn't necessarily mean it is always preferred. Now we have the new alternate table design. This one is based on the assumption that each customer in my customer table can have one or more phone numbers. But it is also true that each phone number could be used by one or more customers. And we took the example of saying that Western Washington Builders, customer 2, uses 666-999-1212 as their primary phone number, and that is a main switchboard. But it's also true that each of the subsidiary entities or DBA entities for Western Washington Builders also use that same number. So rather than duplicating that phone number multiple times, once for each use by a customer, we're going to say we will create a table that will stand between our two customer table and phone tables. And instead of duplicating data, we're going to duplicate foreign keys. So I've created this table. I'm going to add some records, and then I'll show you the design view of this table. Customer 2, Western Washington, foreign key pointing back to primary key for customer name, Western Washington. They use phone ID 6, and it is their primary number. However, Rainbow Heights, which is customer 4, also uses that same phone number as their secondary number. And the same is true for 5 and 6, which are the other two limited liability companies that are owned by Western Washington Builders. So now, instead of duplicating data points, and one of the main reasons we're very reluctant to do that is that you can easily get typos, and all of a sudden you have 3 versions of the same number, and it can be more difficult to sort out which one is the correct one. With this design, there's only one place to make a mistake. Now, if you make a mistake, it shows up everywhere, but there's only one place to correct it as well. So with this design, we're able to assign each customer to 2 or more phone numbers, but we're also able to assign each phone number to 1 or more customers. Now we can come back and do the same thing here. We'll add a new phone number. And we'll say that this is a fax, company fax number. And we're going to say now, okay, customer 2 also uses phone number 7, and that is other. Now we know that it is a fax from the phone table, and we know that it is the third choice for this particular customer because of the priority here. The final step will be, again, we're going to get rid of this number, this field here, And I'll go in and rename it to Z, and later on we'll come back and delete it. So this is how we handle those cases, and I'm repeating myself, make sure it's clear. If a given phone number can be used by 2 or more customers, or if one customer can use 2 or more phone numbers. This is called a junction table. This is the name that I learned to use for it. I think I've heard it referred to as other names, cross-reference table being one, but I learned a junction table when I was starting out, and that's the name I still use. And it creates the junction between each of the items here and each of the items here. Let's look at how that is set up. We have 2 keys in this field identified as the primary key, not just one, which we've seen in previous tables. We want to do this because we want each combination of customer and phone to be unique. In other words, I don't want to put phone number 555-666-4545 in this table multiple times for the same customer. That would be redundant. So by designating this as the primary key, I can avoid that. Primary key is unique, so each combination of customer and phone must be unique. We can never have nulls. And this is how you designate a composite primary key. A composite primary key, or you could do it with an index, a composite index in a table. So, kind of wrap it up, we have taken the next step towards building a well-normalized or well-designed relational database, following the principles that are derived from the normalization process. And normalization really is nothing more than a formal way of describing the rules that define how we approach these things. Earlier, I promised to explain a little bit more about the theory or philosophy behind which of these 2 options you would choose. The many-to-many relationship that we have here is the more fully normalized, or the more completely normalized design. Anytime we have this case where we want to avoid redundancy, repetitive data, we want to go to this design which allows us to structure our data in the most compact, efficient way possible. The downside of that is that it does add a little bit more complexity to the interface. So as I said earlier, sometimes we will see developers using this strategy, even though it's not fully normalized. I'm trying to get this moved where you can see it better. Okay. This child table strategy, even though it's not fully normalized, and even though we have redundant, repetitive data here, I have seen very well designed databases that use this approach. I have done so myself. The difference really has to do with how you want to approach the complexity of the interface. The more complex the relationships, the more complex the interface is going to be. So as is often the case, there's a trade-off here between how easy it is to design an interface to go with it, and how important it is to maintain this referential integrity between data points or data elements or entities, the relationships between them. If you're trying to create a very highly efficient, very highly structured database, you're going to go more towards the complex relationship design that handles that better. If you're going for something a little more straightforward, simple, but not as robust, not as flexible, this approach is also used. The choice is really, in the end, up to you. I know database design purists will say you must always go to the most normalized structure you can come up with, but I also know that sometimes just getting the job done is the highest priority. I'll leave it up to you. You can decide based on your own requirements which way you want to go. Keeping in mind, as we make our final step here, this same design will apply to many, many other elements of a relational database. Thinking immediately, we're going to do the same thing for email addresses. We're going to do the same thing for street addresses, locations. There may be other cases where you'll need to take multiple entities from one category and relate them to multiple entities from the other category and vice versa. I'm thinking here, for example, of students in classes. One student takes many classes during the day. Each class has many different students during the day. So that's another many-to-many relationship. These are probably the most commonly encountered relationships, although the one-to-many we have here, and I've been referring to it as a parent-child. It's also referred to as a one-to-many relationship. This is also a very commonly seen relationship type. At this point, I'm going to stop, let you digest this. I will come back in the next video, and we'll do the same thing with addresses and email addresses and other tables that we might need to support our growing example database. If you like what you've seen so far, please hit the subscribe button and do come back and visit us soon. Thank you.